Doing problem 2, the worksheet for 7.4. Similar to the example problem, we'll do this one a little bit quicker. So this function is pretty similar to the example problem, so we'll go ahead and graph it first. This is going to be now a parabola opening down. So its y-intercept will be up here at 9. Again, if we plug in 3 here, you see that it will get 0, so if we go out to 3, we know it's going to cross the x-axis right here. The integral is from 0 to 6, so we have to keep going. So if we draw the function as a parabola opening down, we'll see kind of similarities between this and the example problem. Again, I can't quite fit all of it in there, but the idea is that this is the area under the curve, this is area above the curve. We just want to find the total area here. Any area that's below the curve, we have to make that integral negative to account for the fact that it is below the x-axis. And if we didn't make it negative, then it would end up being a negative number. So for the total area between the function and the x-axis, we have to set up two integrals. The integral from 0 to 3 is the first one, 9 minus x squared. And then for the second one, we have to subtract that off because, again, it is going to be negative, so the two negatives there will cancel. We'll get a positive there. So the integral from 3 to 6, same function. So the antiderivatives will be the same. So we'll get 9x minus 1/3 x cubed for the first part, evaluating this from 0 to 3. Then we're going to say minus, again, 9x 1/3 x cubed. This one evaluated from 3 to 6. So plugging in 3 here, we're going to get 9 times 3 minus 1/3 times 3 cubed. Now if I plug in 0, that's just gone, so we'll not bother with that. Minus, now again we have to subtract off the whole thing that we're going to get here. So this is going to be 9 times 6 minus 1/3 times 6 cubed minus, if I plug in 3, I'm going to get 9 times 3. Plug in 3 on the other one, 1/3, 3 cubed. Okay, so a lot of parentheses here. We've got to keep track of all of what we're subtracting, what we're adding. So 9 times 3, that's going to give us 27 minus 3 to the third 27 divided by 3 is 9. And then minus 9 times 6, that's 54. Distributing the minus here, 6 to the third power divided by 3, it's 72. That'll be plus 72. Again, because of the minus here, it gets distributed. Minus, this is going to be minus 27, but again, that minus changes it to plus, so plus 27. And then we distribute the minus here, that is going to become plus, so it's 3 to the third 27, that's going to be 9. Plus 9, but then there's that other minus there, so it becomes minus 9. Putting all this together, should get 54, and if you notice, that is exactly the same answer that we got on the example problem. Not really surprising because that one was the same kind of function, except it was a parabola opening up. In fact, the exact same parabola, just flipped over, opening up, same interval, so we did in fact get the exact same answer.